Number 26, I take the limit as x approaches pi over 2 from the left, so pi over 2 minus pi over 2 is 0, and tan of pi over 2 is infinity. So I need to manipulate this algebraically before I apply the limit. What I could do, either one of two things, since cotangent and tangent are easy to manipulate, meaning I could say that's over the cotan of x, and now pi over 2 minus pi over 2 is 0, and cotan of pi over 2 is 0, I could apply L'Hopital. So you apply the algebra. Of course, you're not going to really manipulate infinity, but the limit as x approaches infinity, you could manipulate the x. And now you could say derivative of the top is simply -1. Derivative of cotangent is negative cosecant squared of x. That's the limit as x approaches pi over 2 from the left of sine squared of x. Throw that in, and that's the sine of pi over 2 squared, which is 1. Here, if I take the limit as x approaches 0 from the right, remember how the graph of a log looked like. That's negative infinity minus, and sine of x, if you look at the graph, approaching 0 from the right. 0 from the right, that's approaching 0 from the right as well. So that's a negative infinity. That makes it infinity minus infinity. With logs, it's really simple to manipulate, because if you apply the algebra, you could say that's natural log of x divided by the sine of x, a property of logs. And you could say that's natural log of the limit as x approaches 0 from the right of x over the sine of x. If you remember the composition, the limit of the composition is the composition of the limits. So here I do have infinity, I do have 0 over 0. I could say by L'Hopital, that's the limit as x approaches 0 from the right of 1 over the cosine of x. Throw 0 in. That's going to be 1 over the cosine of 0, which is 1, and natural log of 1 is 0. Here again, if I take the limit as x approaches infinity, that's infinity. This is exponential decay, that's 0. The graph of e to the negative x looks like that. So the easy manipulation here is obviously I could just move that to the bottom and make it a positive power. That's infinity over infinity. I could apply L'Hopital, limit as x approaches infinity. That will be 2x over e to the x. That's still infinity over infinity. I apply L'Hopital one more time. Limit as x approaches infinity of 2 over e to the x. And of course that's 2 over infinity, which is 0. And the last two problems, and I'm going to stop here and leave those cases for the next session. I'm looking at this and I notice as x approaches 0, that's 1 over 0, which is infinity, minus 1 over 0, which is infinity. Here, there are no logs, but it's as simple as me manipulating. If you see a fraction, get a common denominator, and most likely that does the trick. And that would be 3x plus 1 times sine of x minus x. And that would be, if I put 0 in, that is 0 minus 0, which is 0 over 0. I could apply L'Hopital, limit as x approaches 0 from the right, product rule. Derivative of the first times the second, plus the first times derivative of the second. Derivative of negative x is minus 1. The product rule as well. That is 1 times the sine of x, plus x times cosine of x. If I put 0 in, I'll get a 0. Plus 1 minus 1 over 0 plus 0, that's still 0 over 0. L'Hopital one more time. This will be 3 the cosine of x. Product rule again, 3 times the cosine of x plus 3x plus 1 times negative the sine of x. The 1 disappears. Derivative of sine is cosine of x. Product rule, 1 times cosine of x minus x sine of x. If I put 0 in now, I'll get 3 times 1 plus 3 times 1 plus 0 over 1 plus 1 minus 0. That will be 6 over 2, which is a 3. I can fix that. So here, also I'm getting e to the 0 is 1 minus 1, that's 0 over 0. I could apply L'Hopital directly. Limit as x approaches 0. 2 into e to the x minus 1 over 1 times sine of x plus x times cosine of x. If I put 0, I'll get 0 over 0 plus 0 is also 0. L'Hopital one more time. Limit as x approaches 0. That's 2 e to the x over cosine of x plus cosine of x minus x sine of x. If I apply the product rule on that piece, that would be 2 times 1 over 1 plus 0. That would be 2 over 2, which is a 1. And there's the homework, section 4.5. This is the first part. The second part is not that long. You're going to do 1 through 49. You could do the odds, or you could do every other odd. This is a refresher because we're going to need that for section 8.8 and the majority of chapter 10.